Hi, welcome to our pre-calculus. Topic today is sum and difference identities, problem type 2, radians. So, identical to the previous lecture, except that over there we have degrees and here we have radians. Otherwise, it's same ideas. So, let's go after the problems themselves. What does this identity remind us of? By now, you should have all of these in your mind. Tangent of a plus b was tangent of a plus tangent of b over 1 minus tangent of a tangent of b. So in the early exercises we were going from left to the right, and now we are going from right to the left. So two angles were being added and the tangent were being calculated to result in such a construction. So this is really just tangent of the sum of these two angles. You have pi 7th plus 3 pi 28th, and we just calculate this by taking a common denominator. So I have to multiply this first one by 4, becomes 4 pi plus 3 pi, and that is just tangent of 7 pi 28th, and that is tangent of pi 4th, and tangent of pi 4th is just 1. If you calculate these things by a calculator and do the same thing on the left hand side, it all depends what the calculator will give you. Perhaps it's going to give you 0.999 or 1.001, etc. Because of finite precision of the calculator. So the idea here we are calculating exact value using the identities as opposed to just typing the numbers into a calculator. How about this one? Well, remind yourself of the formula for the sum of two angles whose sine is being calculated. The sine of the first, cosine of the second, plus cosine of the first, sine of the second, or some expression like that. So this is going to be sine of sum of the two angles. We have 4 pi 5th plus 5 pi 5th, and that is of course sine of, when you take a common denominator, is 4 pi plus pi, and that is obviously 5 pi over 5, and that is sine of pi. And we recognize pi is one of our famous angles. Sine, we know, is 0, so the answer will be 0. How about this one? Sine cosine minus cosine sine. That is of course the case of the formula for difference of two angles. That's the sine of the first, cosine of the second, minus cosine of the first, sine of the second. Sometimes they, in order to abbreviate, they make the formulas show both of these at the same time. So they write sine of a plus or minus b, and the right hand side you see plus or minus, and that indicates either of the formulas can be used. So in this case, this is just sine of difference, so 17 pi minus 11 pi over 18, and this is of course sine of, we have 18 common denominator readily available to us, 11 pi minus 17 pi minus 11 pi, and sine of 6 pi 18th, which we simplify as pi third, and that is radical 3 over 2. How about cosine? Cosine, well, remind yourself of the formula for cosine of difference of two angles. Cosine of A, cosine of B, plus sine A, sine B. Notice this is subtraction here, and here is the addition. So this is cosine of 6 pi 7th plus 11 pi 7th, and that is cosine of, adds up to, oh, excuse me, I made a mistake here. This one is, okay, 11 pi 21st, so 6, take a common denominator, 21. So that's, I have to multiply the first multiply by 3, so it becomes 18 pi plus 11 pi well, here we have kind of a odd situation. This is 29 pi 21st. Okay, it's not one of the famous angles. It's just another angle, and since we want to find the exact value, then that's what we are going to enter and leave it at that. There's nothing further to do here. Make a mistake here, sorry. I'll go back here. Good that I tried to remind myself, but I didn't. This is difference of these two, not the sum, so that was silly of me. So cosine of, this is 7 pi 21st, and that is cosine of pi third, and that one is just 1/2. Sorry for that mistake. So cosine plus sine is cosine of a difference. I made a mistake of writing sum here and ended up with the incorrect answer, and it wasn't a famous angle either. So we corrected this thing and ended up with cosine of pi third, which is 1/2. How about the case of tangent? So let's write the formula for this one as well. Tangent of the difference of the two angles is tangent of A minus tangent of B over 1 plus tangent of A tangent of B. We saw that at the beginning for the case of the sum. If you want to write it for difference, this is minus, and then this one is plus. So the convention is that the first ones go together, all the operations you see in white and the operations that you see in red, they are tagged to each other. So in this case we have the case of tangent of difference. So this is going to be tangent of 11 pi over 12 minus pi fourth. So we take a common denominator, 11 pi minus, that's going to be, I have to multiply by 3 pi, so tangent of, that's going to be then 8 pi 12. We don't leave it like that, simplify by 4, so that's going to be 2/3. So tangent of 2 pi third. We said you can use your table, but here's another way of doing it. Tangent of 2 pi third is of course same as 120 degrees. So if you have 2 pi third, this angle will be minus pi third. Both of these have the same tangent of minus pi third. Now you can apply the even odd identities. It's minus tangent of pi third, and it becomes minus radical 3. So I suggested that you go through geometrical reasoning for this. However, if you want to use your table, feel free to do that. Okay, so what we learned here, applying the sum and difference identities in reverse. That's what type 2 meant. We are applying this thing in reverse, and we were using angles in radians. Just to paraphrase everything, so we had sine of a plus or minus b, so that is sine of the first, cosine of the second, then plus or minus cosine of the first, sine of the second. For cosine of a plus or minus b, we had cosine of the first, cosine of the second, minus or plus, so in reverse order, sine of first, sine of second. And then if we have similar thing for tangent of a plus or minus b, the formula for this one is obtained by simply dividing these two formulas and simplifying, and we get the following interesting expression: tangent of a plus or minus tangent of b, in the denominator is 1 minus or plus tangent of a tangent of b. So do yourself a favor, write all of these things multiple times. There are also similar identities for the other trig function. You might be wondering what happened to cosecant, secant, my cotangent. Just to make it more manageable, we are focusing on the primary group, sine, cosine, tangent. The other ones are rather similar. Okay, until next time, where we are going to look at other applications of sum and difference identities. Good luck and God bless.